So in your notes, we're just going to talk about a couple last things about changes of state. We'll name them. We'll talk about what graphs look like when we record data as a substance is changing from one state of matter to another. But first, just some terms, and I think you know all of these. So if you're adding heat to a system and a substance changes from a solid to a liquid, raise your hand and tell me what's the term we use for that. It's not, it should be easy. Jimmy?
Melting.
Yeah, melting. How about when something changes from a liquid to a gas? There's actually a few terms we might use. What's one, Natalie? Evaporating. What's another one? Vaporization. And there's one more. Probably you would call it in your kitchen. What? Boiling. Any of those terms are fine. Vaporization, evaporation, boiling. That's a change in state from a liquid to a gas. So those are changes that happen as we add heat. When we remove heat, we have some other terms. When we remove heat and something changes from a gas to a liquid, Brandon? No. Condensation. When we remove heat and a liquid, it changes into a solid. Right?
Freezing?
Yeah, freezing or solidification. Now there are instances when a substance will skip a state and will go directly from a solid to a gas without ever going through a liquid phase. Dry ice is one example, and probably the most common example. Have you ever seen dry ice?
Yeah.
You know, sometimes they pack stuff. They're gonna send some like frozen meat to you from somewhere across the country. They'll often pack it in a cooler with dry ice in it. And the reason they use dry ice is because when it doesn't melt into a liquid, it goes from a solid directly to a gas, and so it's not going to make the package all wet and so on as it changes state. The term for that, some things also go from gas directly to solid. Sometimes we call that sublimation. There's actually another term, deposition is probably a better term, but we're not going to really use that. Or solid to gas, we also call it sublimation.
Are we ever going to do dry ice again?
I don't know. Probably not.
Aw.
All right, so those are the terms that we're going to use. So let's look at here a typical graph. Most of the time, if we have a substance and we're adding heat to it and recording the temperature over time, it will create a line that looks something like this. And these lines, they have areas where the line is increasing, areas where it flattens out, okay? And we're going to talk about what is going on at those various places, because when we did our lab on Friday and you were recording the data, you took your ice, you put it on the hot plate, and then most groups thought something was wrong at first.
Yeah.
Why did you think something was wrong? Juliet?
The temperature just stayed the same.
Yeah, you kept saying the temperature's not changing. The temperature was at whatever, 1 or 0, and it was staying that way. Even though it's on a hot plate that's been turned up to 550 degrees, the temperature stayed around 0 for a long time. Okay? And there wasn't anything wrong with what you were doing. Okay? You did everything right. That's just the behavior. That's what happens to temperature. So, did anyone's ice start off below 0, like -2 or -3? What was it, Peter?
-2.
-2?
-2.
-2? And then it increased to 0? Okay. So in that time when it was -2 and -1 would be here, this part of the graph. So we can label it, when it was in that phase, what phase of matter was it? Well, what would we call that in general? Yeah, it's a solid. Okay. Then as you added heat to it, put it on the hot plate, when you guys start saying, well, something's wrong because it stayed at 0 or so. Okay. What was going on there? The time that it stayed around 0, how could we describe what was going on at that time? Nicholas?
Melting.
Yeah, it was then melting. Okay? On my slide, they're out of order, but yeah, that was melting. Then when did the temperature start to increase again? Ryan?
Oh, when it was like all liquid.
Yeah, when it was completely melted, and then it was just a liquid, then you saw that the temperature started to rise. It was a liquid in this area. But then again, you saw that the temperature, once you got to a certain level, the temperature leveled off again. Around what temperature? Right around 100. What was going on there, Brandon? Boiling or evaporating. And then you didn't really get to this phase because yours continued to boil and we were out of time. And we didn't track the evaporating water, so we couldn't really continue to measure the temperature. But if you had tracked that boiling water, that gas, and measured its temperature, once all of your liquid water was boiled and changed into a gas, right? If you were able to continue adding heat and contain that and measure its temperature, temperature would continue to increase after that. Okay? So in here, melting, what do we call this? Boiling, evaporating, vaporization. Yes. Brandon?
Are humans solids or liquids?
Well, we're a mixture of materials.
So what are we called?
Nothing. Now, there's a couple things to keep in mind in the lab that we did on Friday. Did everybody's ice melt? Was it consistently at 0?
No.
What did yours do, Sophia?
It was consistent and
Oh, yours all melted at -1? Okay. Well, let's talk about that first of all, because I told you, what do we know the freezing point or melting point of water is? 32 or 0. So we would expect that your graph should have stayed at 0, but the data doesn't always work out perfectly. There are some reasons for that. What's one reason why it may have seemed to melt at -1? Nicholas?
There were other liquids involved.
Okay, there may have been some impurities. Okay? We're going to talk tomorrow about the effect of salt and other substances on the melting and freezing point of water. But there could have been some impurities that changed slightly the melting point. What else, Sophia?
no, I was going to say something about the salt.
What
When
about
I
it?
got home, I put salt on my ice in it, and it started to sting, but then I took I brought my sister over and I gave it to her, and I pushed it down really hard.
That's not very nice. That's cruel. All right, so what are some other reasons why it may not have been right at 0, Ryan?
Some ice might have melted, but other ice might.
Okay, sometimes that happens, like most of the ice is melted and the water sort of separates by density. That could have been part of the issue. How about the tools that we're using? Yeah, they can be a little bit off. Okay, the thermometer, any tool that you use to measure anything is not 100% accurate. There's always some margin of error in any tool you use to measure things. And these thermometers are no different. On some of them, somebody mentioned this, I forget what period it was, but that the column of liquid in there was separated, that there was like a little gap in there. And again, that may influence it a little bit. And they just may not be 100% accurate. So you may be off a degree or two. Okay? And that's okay. That's the data you got. Whenever you're collecting data, there's going to be some margin of error. So it's not that you did anything wrong. It's just there were some areas of error. Also, where the bulb of the thermometer is located may have some impact. Because if the bulb of the thermometer is directly touching the glass, well, some heat transfer may happen through conduction and artificially elevate it a little bit. So those are some other things that might come into play. Julia?
It stayed at 5.
At 5 degrees the whole time? All right, well,
Yeah.
I mean, while it was melting. And again, that's probably a problem with the thermometer, probably a very inaccurate thermometer. There may be some issue with it. So those are all reasons why we may not see things work out exactly as we theoretically think they should. All right, if we finish up here, if we're going to label this graph, now are we adding heat or removing heat? Removing heat, because the temperature is dropping. What do you think this would be up here? How about some new hands? I keep seeing the same people. Peter?
Yes.
Yeah. What would be going on here, Habib?
Evaporation.
No?
Oh, not my condensation.
Yep. And then here, Linda? Yep. And then here? Matt?
Reason.
Yep. And then finally the last little section there? Brandon?
Solid.
Yes. Okay, so when we're going the other way, we just have different. So whenever we're looking at these sort of graphs, the flat areas, the plateaus, are always a change of state. Melting, freezing, boiling, condensing. The areas where the temperatures increasing or decreasing are always one single state of matter, solid, liquid, or gas. Okay? You're going to have to label these and interpret these graphs on your quiz on Thursday. Brandon?
Yesterday my blood